Let's have a look at significant figures, and in particular rounding using significant figures. And I'm going to start this off with an example. Let's say a car was priced at $35,286.18. Your first thought would probably be, who cares about the 18 cents? In fact, who cares about the $86.18? You would think that surely there's got to be a more appropriate way of pricing this car, considering that these last few digits are probably not important. Okay, I mean, you got cents, you got dollars, tens of dollars, hundreds of dollars. I'll probably get to the hundreds of dollars. You'd say, okay, that's probably an important number. That's an important number. That's an important number there. So the last four digits obviously seem unimportant or not significant, considering the size and the value of the numbers before them. So that's the tens of thousands, that's the thousands, that's the hundreds. The tens, units, and the tenths and the hundreds seem insignificant, don't add much to the value. So it would make more sense for the car to be priced at $35,300, in other words. So rounding using significant figures really keeps only those numbers whose value is significant. And so another word for significant is important. So the 3 is important in this example, the 5 is important, probably the 2 is important as well. The 8, 6, 1, 8 are probably not. So 35,300 is an example of rounding $35,286.18 to 3 significant figures. Let's have a look at the rules in a bit more detail when it comes to rounding with significant figures. Okay. So rule number 1, probably the easiest one. The first non-zero digit from the left is the first significant figure. Let's say, for example, I was to write a number 2,358, and I've put some leading zeros here. Well, the leading zeros really don't do anything. Okay, they don't add anything to the value of the number or even change the number. They're useless. So we don't count these as significant. So the first significant figure is just the first non-zero digit. So this one's a fairly easy one because we rarely ever write numbers like this. It's always a number that starts with a 1 to the numeral 9, okay, or the number 9. Nothing starts with a 0. Rule number 2, zeros at the end of a whole number or at the beginning of a decimal are not significant. Okay, so as an example, if we had 2,358,000, okay, these last 3 zeros are not significant. Okay, they're only important only to the extent that they allow or they ensure that the 2 is a millions or the millions place. It ensures that the 3 is the 100,000 place value, or the 100,000 place. The 5 is the tens of thousands. 8 is the thousands. So if these zeros were not there, then it would actually be the number 2,358. So these zeros are important only to that extent, but they're still not considered significant. Likewise with decimals, these zeros here are only important only to ensure or to maintain the place value of the non-zero digits or the digits that precede the zeros, that follow on from the zeros there. So 2 is the first significant figure. These zeros are not significant. Okay. Now, you might ask the question, what about zeros that are in between then? So I might just do a little side note here. So if we had 0.02058, these zeros are not significant. Okay, so I'm just elaborating on rule number 2 just a little bit further. These are not significant. Okay, that 0 is significant. Okay, these are significant. Okay, sorry, I just can't fit the whole word there. So that's okay. So these first 2 zeros here are not significant. 2058, these 4 digits here are significant. Okay, you can't have a significant figure, a not significant figure, and then have a significant figure after it. It doesn't work that way. There must be one after the other consecutive, and then at a certain point they're no longer significant. Okay, so this 0 here, that one is significant. Okay, very important to note that. Okay, moving on then to the last rule. Okay, that the last significant figure needs to be rounded up where necessary. Okay, and zeros added to ensure that the place value of the significant figures is maintained. So as an example, if we had the number 15,523 and we want to round this to two significant figures. Well, two significant figures means that really we need, starting from the first significant figure, which is a 1, we want the 5 as well, okay? But the problem is that the numeral, the number next to the 5, which is another 5, means that this 5 here, the first 5 needs to be rounded up to a 6, okay? These first two digits here are really the only ones that we care about. The others are all going to become zeros. So the 3 becomes a 0, the 2 becomes a 0, this 5 becomes a 0, but the 15,523, it's closer to 16,000 than it is to 15,000. And that's another way that you can think about significant figures. Rounding to two significant figures, at least in this case, means do I round it down to 15,000 or do I round it up to 16,000? Which of those thousands is it closest to? 15,523 is certainly closer to 16,000 than it is to 15,000. Okay, so that's basically a good way to think about that. Just one last point and how this applies to measurement. The precision of a measuring instrument. And remember, precision is really the smallest unit that the measuring instrument can measure. It also is the gap between the markings. So, for example, actually I'll just give you an example of precision here. If we had, I don't know if this is going to work, but I'll try. Let me see if I can get that to refocus. Probably can just see that. Yep. So, sorry, it's a little bit out of focus. But if you look at the markings, even though there's no numbers there, the spacing between the markings, in effect, is the precision, the gap. And the gap is 1 millimeter. So the precision is 1 millimeter. How does that apply, though, to significant figures? Well, the higher the better the precision, the more significant figures we can use. Let's have a look at an example. So a tape measure has a precision of 1 centimeter. Okay, so that's a standard regular tape measure. A reading of 32.2 centimeters was recorded. Now, the first question is, how do you record 32.2 when the precision is 1 centimeter? But somehow that's what got recorded. It seemed like someone tried to estimate this reading. Is this correct? Clearly, no, it's not. What should the reading be? Since we're given 3 digits, but the precision's to the nearest centimeter, it should only be 2 significant figures. So the reading should be 32 centimeters. Correct to 2 significant figures. Let's have a look at another example. So basically, or almost the same tape measure. Okay, this tape measure though has a precision of 0.1 centimeters. So that means it could measure to the millimeter. A reading of 32 centimeters was recorded. Is this correct? What should the reading be? Again, the answer is no. You would think, but why is it no? The precision, it could do tenths of a centimeter, yet the reading should indicate that. So in other words, if I wanted to indicate to somebody else reading this number here, reading this measurement, that it has been measured correct to the nearest millimeter or the nearest 0.1 centimeter, the reading should be written as 32.0 centimeters. And this would be correct to 3 significant figures. Okay. Now after rounding, if this 0 here is now significant because this indicates that I've actually measured it correct to 3 significant figures, and it just so happened that the 0 happened to be, well, basically where the reading landed on exactly on the 32 centimeter mark. So this 0 here is important and you must show it if you are to round to the correct number of significant figures. Okay? Hope that makes sense. If you have any questions, any queries, please email me. I'm happy to do another video where we might look at some other examples. In fact, there's another video that'll follow this where we'll just look at some quick examples of just arbitrary numbers that we're going to round to so many significant figures, just to give you a little bit of practice. But hopefully that makes sense. Thanks for listening. All the best.